Yes, good afternoon to all of you. So, we are continuing the same chapter with force. So, in our last class, we have studied about uh, law of motions, which was been given by Sir Isaac Newton. So, in our last class, we have discussed about the Newton first law of motions and the Newton second law of motion. Let's revise once what is Newton first law of motions. Newton first law of motions what is state that a body will be in the state of rest or motions until and unless external force, unbalanced external force applied on it. So, simply we say that it is a tendency or the property of the body that tends them to in the state of rest or motions until and unless a unbalanced force applied on it. So, this was the that we have studied in our last class. Then again we have also studied the Newton's second law of motions. So, what is the Newton's second law of motions? We must intact in our mind the formula, what that is F equals to m into A, okay, or A is directly proportional to the force applied and inversely proportional to the mass of the object. So, what is Newton's second law of motions? Newton's second law of motions state that the force applied on the object, is directly proportional to the acceleration produced on an object and inversely proportional to the mass of the object. So, we have do the derivations also. Just you take the example, one of the example by itself. When we kick a football, suppose we are kicking a football, it will move far when we hit means heavily. And if you take a shot put, the iron ball and keep there and kick by your leg, what happen? What happen? It is possible to kick by your leg? No, because the iron ball has heavy mass, due to which it needs much force than the ball, okay, football. Therefore, it cannot be travel with our by kicking by our leg. So, that is inversely proportional. The acceleration produced is inversely proportional means what? If the mass of the object is heavier, then its accelerations will be less. If the mass is less, then the acceleration will be more, or we can simply look after with the example 10 divided by 5. How much it will come? 2. Okay. If you 5 divide by 10, then what happen? It will 1 by 2. So, when the mass is increased, suppose this is the mass. When mass is increased, the numerator we will keep same one. When the mass is increased, then what happened? It was 5 kg mass, then its acceleration is 1 meter per second square. And when the mass is increased double, that 10 kg, at that time what happened? It will increase by 0.5 meter per second square. That means that acceleration produced in a body is inversely proportional to the mass. When the mass increase, acceleration will be decreased. When there will be decrease in mass, the acceleration will be increased. And we have just now I have give you one of the example that you can easily kick a football than the shot put. Shot put you cannot kick, okay, iron ball. So, now comes to the next one. Today we will continue with Newton third law of motions. So, Newton third law of motion is especially all the students by heart that one. For every action there is is equal and opposite reaction. Okay. So, for every action, state that for every actions there is equal and opposite reactions. So, what it means? What it means? That means that when we force our hand to the wall, at that time wall will also force in our hand equally. Okay. If the unbalanced force is there, then the wall will collapse. Okay. That means that when we press something, at that time the force by which we press, that will be the what? That will be the action, and the force by which the parts that we are been forcing on, that will create a reaction. Suppose this is a wall or duster, let us take an example of duster as a wall, then we will force by hand, then what happen? It will force to our hand, and that will be what? Reaction. That will be what? Opposite force, isn't it? We are pressing this side and the wall is pressing this side. That means that our force are equally expressed in that part. Okay. That therefore, it is defined that for every actions there is equal and opposite reactions. Equal and opposite reactions. And the questions may arise that if opposite means minus, suppose we are forcing with x Newton here. Okay. Suppose our force is x Newton and the wall is forcing us with opposite means minus. Yes, opposite means minus, then that will be negative force. If they are positive and negative force, why we should not cancel this one to make 0? Why? What happened? The questions will be asked in reasoning questions. The questions will be asked that if the force is equal and opposite, then why we will not cancel this one? It will be 0 if it can be possible to cancel, but we cannot cancel that one. We cannot cancel that one. Why? What is the reason we cannot cancel? Because the force is act by my hand. Yes, the force is act by my hand and the opposite force is act by the duster. That means the two different body are expressing their force. If it is from the same body, we can cancel it, but if it is act by the different body, we cannot cancel. That is why we cannot cancel. Do you understand this one? I think you are clear about that one. So, Newton's third law of motion state that for every actions there is equal and opposite reaction. By how much heat we will throw the ball on a wall, that will what come back to our hand with that similar force. Okay. Now comes to the some of the reasoning questions related with the third law of motion. If we say that while going, I think you have went to the some of the lake like Fawatal, you may see that some of the persons are boating, rowing that one in a boat. They are pulling water backside. Why? What is that is the action taken by the rower. Okay, and the boat will move forward as a reaction. That is Newton's third law of motion. Okay. Next one is the while flying a rocket, at that time the fuel burns. The fuels burn with a heavy means force towards downward. So, when the fuel bounds toward downward, it will force the rocket to upward direction. So, what is the action? The fuel burning towards the downside, and the movement upward is the reaction. That is the reaction. So, you can take one of the balloon, and when you fill up with air and leave it, what happen? Leave the mouth, it will move front side. Yes, the air come out this side and it will go front side. That is the Newton third law of motion. So, till here the theoretical portions is been finished with the some of the formula. Let us take some of the numerical examples. So, it will make you easy to practice all the example from the books. I have taken some of the different way to solve the problems in different formula. Let us take the first one. It is noted down in a board. You can write it that one, or you can see from your book also, but you should have the concept regarding that one. Let us take some of the. So, what are the formula that we have studied in this chapter? We have studied what? Equation of motion. Equations of motion. What are the equations of motion? V equals to u plus at, s equals to ut plus half at square, and another one v square equals to u square plus 2as. Then Newton second law of motion, what it gives the formula? F equals to m into a. So, and the other one, that is we have upward directions, we have changed the formula with the height and gravity. So, relating to this formula, we will do some of the numerical problems over here. Let us take some of the example. I will write here so that it will make you easy to which types of formula is to be used in which questions. Let us first one. You can see here the questions is been written. So, a bus is moving with a velocity of. A bus is moving. So, what it denotes? Things to be remembered. I have said the bus is moving. A bus is moving means what? That is given what? Initial given. Number one question, initial velocity. Solution, okay. Initial velocity what? U equals to 72 kilometer per hours. So, 72 kilometer per hours. Kilometer per hours is the SI unit? No, it is not the SI unit. Therefore, we cannot use that one. So, therefore, we have to convert into meter per second. So, how we will convert into meter per second? So, we have to convert 72 kilometer means how much meter? If we will multiply by 100, it will change, sorry, 1000, it will change into meter. Yes. Then the next one is the hours. Hours means 60 minutes. Minute is the SI system? No. Therefore, we have to take another 60. 60 second means 1 minute. It is now it changed into second. Then what will be? This one is been cut off, and 6 means 2 means 20 meter per second. So, what is the initial velocity? Is 20 meter per second. Now, comes to the next one. A diver apply a brake. The diver apply a brake means what? Final velocity 0. Final velocity v equals to 0. Okay. Then the next one, and a bus come to rest. Obviously, when the brake is applied, a bus must come into rest, and the time is given, the come to rest in 3 seconds. Second means time taken. Time taken how much? That is 3 seconds. For what? For the bus to come into rest. Now, what is the another one? It said calculate the retardations of the bus. That means acceleration. Acceleration, or we can write retardations also. It will come in negative. Okay, that is minus a retardation. We will write. So it is written in question. Therefore, retardations equals to what? Now, so according to, now what types of formula we can use? See here, first u is there, v is there, t is there, and a is there. A is to be found out. Anything is there for distance? No. Therefore, s, we will not use the formula related to s. We will use only the formula related to the u, v, t, a. So, which one? That is the first equation. Okay. So, we have from equations of motion, v equals to u plus at. Yes, v equals to u plus at. What is the unit of v? Or 0. Yes, u how much? 72 kilometer per hour. Can we write this one? No, we have to write SI unit, that is 20 meter per second. Most of the students will confuse. They will write the same which is given kilometer per hour. So, you must be clear that you should change into the SI unit. Then acceleration upon time taken how much? 3. So, let us take this one this side, 20 minus, when we carry this sides, then what happen? Then it will minus 20 meter per second upon a 3 second. So, a is how much? A we have to find out, then 3s. Okay, 3 second. Then what happen? A equals to, or a equals to minus 20 upon 3 meter per second square. Yes, s and s meter unit. So, 3 how much? 3 6 18 point, again to remember 367 meter per second square. Therefore, a equals to, therefore acceleration retardations, what it is in minus. So, minus means what? Retardation. Therefore, retardations of a bus is 6.67 meter per second square. Okay. So, in this way we can calculate the means do the solutions. Now, next try the next questions. A car is traveling with a speeds of 60 kilometer per hour again. So, we will start the question number 2. So, for this you can pause it the video and you can watch it and write down. Now, let us take the another example. So, for shortening of time I will not rub this one. The initial velocity, the car is traveling, moving means that the given velocity will be u. A car is traveling with a speed of 60 kilometer per hour. Here again we have to change kilometer per hours, means we have to change this one into meter per second. Let us change 60 into 1000 upon 60 into 60, that is minute and second. So, one is gone, this one is gone, then how much? 50 upon 3 meter per second. Don't change into the point, okay? It will make you easier to calculate. So, it is not necessary to change to the point. Then again, so what we get? 50 upon 3 meter per second. Then what happened? On seeing a boy 11 meter, what the diver saw a boy standing on a road at 11 meter. So, they see means what? It is, there is no any actions is been taken. Therefore, we should not be confused that by seeing we will write the distance is s. No, let us move forward. Ahead on a road, the bus stopped at a distance. Now, it is given a bus stopped at a distance of 10 meter. Now, what is given here? Distance given. Distance, that is s, equals to how much? 10 meter. 10 meter. The bus come to rest at 10 meter, but it saw a boy at 11 meter. That means the difference between the bus and the boy is 1 meter apart. That means the accident does not take place. What is the retardations? So, retardations is been given. So, to find out, the bus stop at a distance of 10 meter. What is the retardations n? Then final velocity will be 0. So, time is given? No, time is not given, distance is given, and again what it asks? It asks the retardation. Retardations equals to what? Then how long does it take to come to rest? How long does it take? How long means what? How long means time. Time taken to be in rest. Okay, t equals to what? So, what are the s is given, v is given, u is given, a is needed or t is needed. So, can we use this formula? No, because you always remember that there are 4 parameters. Out of 4 parameters, you must have 3 parameters. 3 parameters should be given in question, otherwise you cannot solve the question. Therefore, we will search that one v, u, v and s. So, we can use this formula, okay, or we can use this formula. First, we will find out the acceleration. So, now what we will do? Now, from the equations of motion, we have what? V equals to u plus at. Yes. So, v means how much? 0, u means how much? 50 upon 3 plus a means how much? It is to be find out, and time is how much? Time is not given. So, can we use this formula? This is one of the example. A is also unknown, t is also unknown. Can we use this formula? No, cannot. Why? Because 2 things cannot be find out at a time. Only one thing can be find out at a time. Therefore, which formula will be suitable over here? that will be suitable. Which one? That will be suitable. V square equals to u square plus 2s. Are you clear what I said? This one? Yes, v square equals to u square plus 2as. Now, acceleration is needed, distance is given, initial velocity is known, and v is given. 0 equals to 50 upon 3 whole square plus 2 into a into s means how much? S means 10 meter. So, 10 meter per second. 50 into 50 square is 2500 upon 9 equals to or 0 or plus 2 into 10 20 a. Okay. So, we can carry this one here 2500 upon 9, that is minus equals to 20 a. Again we can carry 2500 upon 9 into 20 equals to a. So, how much it will be? 0 0 gone, the 125 upon 9 equals to a. Then how much it will be? So, that will be 9 1s are 9, then 9 3s are 0.889. Okay, that is meter per second square. A equals to minus 13.9 meter per second square. So, this is the acceleration produced in a body. Okay. So, the acceleration produced in a body is this much. Now, what is to be found out? That is time taken to be in rest. Now, we can use the first formula v equals to u plus at. Now, v equals to 0, u equals to 50 upon 3 plus a means how much? 13.89 into t. Okay. So, we can carry this one here, that is 13.989 how much? It is a minus, we remember that one. So, we will carry this one 13.89 t equals to 50 upon 3 again. Okay. Then t equals to 50 upon 3 into 13.89. Then t equals to how much? It will be 49 something 1.3 meter, sorry, second. Something is one. You can calculate 1.25 or something it will comes. Okay. You calculate this one. So, in this way we can calculate this one. Let us try the another one. Third question, a force act on a body of mass 2 kg, means mass is given, mass m equals to 2 kg. A force is act on a body 2 kg. The velocity of the body change from 15, means velocity, change velocity from 15 meter per second to 40 meter per second. 40 meter per second. In 4 seconds, time is given, time taken 4 seconds. Then calculate the force applied. Applied force equals to F equals to how much? So, now, according to Newton's second law of motion, before that change in velocity means what? 15 is what? 15 meter per second is the, let us write here clearly, change in velocity 15 meter means initial velocity u equals to 15 meter per second final velocity v equals to 40 meter per second, and t time is given how much? 4 second, and we have to calculate force. Okay. Now, before we have to find out what? That is A. According to Newton second law of motion, F equals to m into A. So, F we have to find out mass, how much it is given? 2 kg, and acceleration means what? Let us take in bracket, what is 40 minus 15 upon t, how much? 4. Do you know this formula? V minus u upon t. I take since. Okay. So, 2 into 40 minus 15, how much? That will be 25 upon 4. Then 2, then equals to 12.5 Newton will be the force applied on an object. So, in this way we will practice the numerical, we will do the numerical. Now, there are another example is been there, you can do it at home. So, this is chapter we have completed today up to here, and from tomorrow you will have your chemistry class. It will be taught by the another teacher, and after having some of the chemistry chapter, then we will continue our physics chapter. Till then, thank you to all of you for your watching and cooperating with us, and hope to meet you again, and thank you to all of you, and good day. Thank you.